now that I think trials are over for most of you, I thought that we would just go through some of the concepts that we kind of tend to overlook a little bit. And these are places where we can get a lot of marks in exams if we know what's going on. So yeah, making sure that you understand what is going on in statistics is really, really important. These are easy marks, and every single one of you should be getting, what's this one out of? 9 out of 9, and this one's out of, I don't know what, 7 out of 7, whatever the case is. So we've got to make sure that, because it's going to be the first question that we encounter in paper 2, you've got to make sure that we're getting as many marks for this particular section as we possibly can. And just in marking trials recently at my school, I was actually surprised. This is one of the questions I marked, and it was just interesting that there were so many people who actually didn't get any marks at all for the grade 11 or grade 12 statistics. So I thought, let's go through that, and yeah, just make sure that you guys are where you need to be with this. All right, so the first question tells us that a survey was conducted at a local supermarket relating to the distance that shoppers lived from the store to the average number of times that they shopped at the store in a week. The results are shown in the table below. Okay, so when they give us a table like this, how do we know which one goes on the horizontal axis and which one goes on the vertical axis? How would we know? How? How can you see it? Kaiser, we're not determining whether things are dependent. Okay, so the first row is always going to be the variable that goes on the x-axis. Okay, always, always, always. So if you're not 100% sure, lucky for us, they keep doing things the same way. So x is the first one and y is the second one. All right, every single time. All right, so your first row is the x's, your second row is the y's. If you have a look at your scatter plot, you can see distance from store is on the x-axis and average number of times shop per week is going to be on the y-axis. So they've given us these pieces of data and they've plotted the points. Does everybody know how to plot the information onto the scatter plot? I mean, if they didn't give you the points, would you know how to draw them if they asked you to draw them on the scatter plot? That's what I'm trying to ask. Okay. Yes. Okay, cool. All right, so they work as a pair of coordinates. So 1 and 12, 2 and 10, 3 and 7, etc., etc. Okay, they've given us this particular scatter plot, and they've said to us, use the scatter plot to comment on the strength of the relationship between the distance a shopper lived from the store and the average number of times he or she shopped at the store in a week. What would you say? What are we even looking at? I mean, if they're asking us in the second instance, that's where they want us to calculate the correlation coefficient. So they're not asking us to calculate the correlation coefficient first and then basing our answer off of that. So in 1.1, what do they actually want you to look at? Sure, okay, but they want you to comment, Kaiser, they want you to comment on the strength of the relationship. So yes, you're right. The trend of the data says the further that somebody lives from the store, the less often they would visit it. Fair enough. But that doesn't tell us how closely the two variables are related to one another. So what are we actually looking at on the picture? On the scatter plot, what are we actually looking at? So I'm just doing an approximation now of what your line of best fit would look like. What they want us to look at is how close these dots are to the line. All right. So in other words, when two variables are very strongly related to one another, what you will find is that they will be almost in a perfect line. Okay, then the strength between the two is high, okay, if they're in the same straight line. But if you've got a situation where like one is up here and one's down there and one's over there and another one's here and that one's over there, okay, their distance from this line is variable. So this one's closer to the line than what this one is, and that one's on the line and that one's a little bit further away and that one's a little bit further away. So the distance that each point is from the line tells us how strong the relationship is between X and Y. Does that make sense to you? That's what the correlation coefficient actually measures. So in other words, are these dots, are they all in a perfect straight line? No, they're not, are they? Because some are above and some are below. They're not all the same distance from the line, right? No. So what could we say about the strength of the relationship? Would we call it very strong? Would we call it perfect? What do you guys think? No, I agree. So there's definitely a correlation, but maybe what we could do here is we could use the word moderate to strong. You think it's strong. Okay, well, let's calculate the correlation coefficient and see if we're correct. Okay, so now you need your calculators for this. Do you all have the calculators? Medium weak? I don't know that it's weak, Tyler. I mean, if there's no correlation at all, so let's say I decided to measure your IQ, and then I wanted to measure the size of your foot, right? And then I plotted that data. I would see absolutely no correlation between how big your feet are and how intelligent you are. So there would be no correlation at all. Okay, so here there is very definitely a relationship. So I wouldn't say that it's weak. I would say that it would be moderate to strong, probably strong. Okay. Do you know how to calculate the correlation coefficient? Yes. Okay. All right. So let's do that. And once you've worked out what it is, you can put it into the chat. Okay. So I'm going to do the same thing here. I'm also going to work out what it is and we'll see if we get the same answer. Okay. All right. Go for it. Okay, I've got an answer. Tisha, we are calculating the correlation coefficient. Do you know how to do that? Careful with your rounding, Kaiser. If they decide to penalize you 1 mark on your rounding, you would have lost it there. Okay, Kaiser? Just look at your calculator again. That's better. I agree. Okay, so remember, all of these are going to be rounded off to 2 decimal places. All right, so here we would have said negative 0.95. Okay, so moderate to strong. What do you guys think? Was moderate the right word to use? No, I agree. Okay, so we would have said here that there's actually a strong relationship. It is strong, yeah. So remember, if the relationship, so if R is -1, then it's a perfect negative relationship. If R is equal to +1, then it's a perfect positive relationship. So it's really, really close to being a almost perfect negative correlation. Okay, so good. Okay, calculate the equation of the least squares regression line. Do you guys know how to do that? Okay, if you've got an answer, you can pop it into the chat. No. Okay, so Kaiser, did you know how to find the correlation coefficient? Okay, so exactly the same way that you found the correlation coefficient is how you find the equation of the least squares regression line. Okay, so let's just start all over again. All right, so on your calculator, go back to when you were just putting the values in. So in other words, you started off before you'd pressed stat or anything like that. Okay, so then you would choose the mode on the calculator. You'd choose statistics, which would be number 2. And then when that came up, you'd choose option number 2. So A plus BX. So choose option 2. Then you've got 2 columns, right? An X column and a Y column. So put in your X's and put in your Y's. And then tell me when you're ready. And I'm going to do the same, okay? Okay, so Casey, you got, okay, ready, cool, me too. Okay, so now you're going to press AC, shift 1. And then you're going to choose option 5 where it says REG. REG stands for regression. And choose option 5. Now, what do you see under option number 1? What do they give you there on your calculator? What letter? There we go. Okay, so the equation of your least squares regression line, it's on your formula sheet. So it's y hat equals A plus BX. So this A that you see on your calculator, Kaiser, that's the value that you're looking at now. So you're going to press 1 and you're going to press equals. What do you get? Perfect. Okay, I get exactly the same. All right, so 11,71. Okay, now we need to get the B value. Okay, So now you've got to go back to the beginning. So now you've got to, well, not back to the beginning, but you've got to start all over again. So now without pressing anything else, KZ, you're going to press AC, shift 1, 5 for regression. And now you're going to choose option 2, the B. What number do you get? There we go, Tisha. Okay, and then both of those numbers can be rounded to 2 decimal places. Okay, so what they'll give you, actually, I shouldn't have put the X here. Hang on a second, let me just write that out. Okay, so what they do here, the reason that this is out of 3 is these are the 3 marks that they give you. So the first mark is for your A value, the second mark is for your B value, and the second mark is for writing it as an equation. Okay, so you've got to make sure that afterwards you go ahead and you write it like this. Don't forget to put the X in. Okay, a lot of matrics do that and they end up losing that 3rd mark. Okay, so this is your 3rd mark over here for writing it as an equation. Okay. Everybody good with that? Okay. You didn't leave the X out, Kaiser. Okay. All right, there we go. So there, we've done 1.3. So now they want us to use our answer from 1.3 to estimate the average number of times that a person or a shopper living 6 kilometers from the supermarket will visit the store within a week. So the number 6 fits in over here, right? So they are asking us to use the equation of the least squares regression line to make a prediction that lies within the set of data that they've given us. Okay, so we're allowed to do that. So what you're going to do is you're going to substitute. So we've got our equation. We know that it is y hat equals 11,71 minus 1,12x, if I remember correctly. Yes. Okay. And now they're saying to us, let x be equal to 6. So we're going to sub in our 6. And then we can work out the average number of times that person will visit the store. Okay, so you do this bit on your calculator. Oh, share that. I'm still in stat. Okay. Sorry, give me a second to catch up to you. 2 times 6. Okay. Let's see what you guys are getting. Oh, cool. There's lots of answers. Yeah, it would be. Kaiser, it would be. Okay. So yeah, roughly 5 times a week. Okay, does that make sense to everyone? We're all good. You guys are really quiet tonight. You're all exhausted. Hey, has it been a long week? Okay, cool, Promesa. Everybody else? Oh, wow, so you're writing physics tomorrow. Okay, it has been a long week, yes. Okay, you just got to hang in there, okay? You're nearly done. You just got to be strong for another 2 months, which feels like a long time when you say it, but it's going to go by faster than you think. Okay. Do you do physics, Tisha? Oh, okay. So you're also writing tomorrow. What's MD? Oh, excuse us. Okay, sorry, I didn't realize. Sorry, I didn't. I didn't put that together. Okay. Oh my gosh, really? Is it? Why? Annie, but you say you're not looking forward to it. Why? Why are you not looking forward to it? Even me, Tisha, I also want to see pictures. Mr. Bavuma, you're going to post pictures of you and your date. Hey, let us see.
You want to see?
Yeah, of course you want to see. Nelisa and I are very interested. Oh, 9th of December. Wow, that is super late in the year. Next week, Thursday. Have you had yours already, Kanisile? Oh, wow. Okay. So lots to look forward to then, guys. Do you have a nice date, Kanisile? Really?
Only left with 1 week.
You better get a move on, girl. Oh, that's also okay, Kanisile. You can go and just have a good time with your friends. So, Casey, yours is only in October. Okay, so you still got a little wait. The parents. Okay, I get it. I get it. It's just because they love you, Kanisile. They don't want anybody to hurt you. You'll see one day when you're a mom, you'll be exactly the same with your daughters.
And when you're older, you appreciate it.
Yes, absolutely. Oh, goodness. Okay, well, it's much more interesting talking about the matric dance than it is talking about maths, but we better get back to it, I guess. Okay, so now last thing that they want us to do was sketch the least squares regression line on the scatter plot provided in the answer book. So we can sketch it over here. Obviously, what I've done here is just an estimation of what it would look like. That's not actually what it would look like. So yes, back to math. How are we going to work out how to draw the least squares regression line? How do we do that? Can anybody tell me? What do you have to look at? Does nobody know what we're supposed to be looking at? Are we just going to grab our ruler and draw a line on the page? Yes, can you see it? We can, yeah. Or what you can do, can you see them? Is you can look just inside, so just like one bigger than the minimum and say one smaller than the maximum. All right, so in this situation here, we already know that the minimum distance from the store is 1 kilometer, right? So let's start with 2. We already know that when 2 goes in, 10 comes out. But we don't know what happens when 9 goes in. So 9 is just one smaller than 10, which is the maximum distance from the store. But we can work out what that output would be using our equation. All right, so let's calculate y hat. So that's 11,71 minus 1,12, and then 9 kilometers from the store, right? So this gives us a value of, what are you guys getting? I got 1,63. Yeah. Okay, so 1,63. It's okay. It's just a typo. It's not the end of the world. Don't worry, Kaiser. Okay, so now let's go back and have a look at our scatter plot. Okay, so this is where 2 and 10 are. And now we need to plot 9 and 1,63, right? So 1,63, so 9 is over here. 1,63, I guess, would be somewhere over there. Okay, so in order to draw the least squares regression line, you just need 2 points. You only need 2 points to draw a straight line. So you're going to choose a point that's just inside, so a little bit bigger than the minimum, and another point that is just smaller than the maximum. And then plot those 2 points if they're not plotted already. Grab your ruler, connect the dots. Oh, there we go. All right, and that's it. There's the equation of the least squares regression line. If I wanted to, I could take that and I could kind of, oh, I'm not doing it very well. I could extend it a little bit further. So maybe sort of out to about there. And if I wanted to, sort of maybe down to about here, but I wouldn't go much further than that. Okay. Is everybody happy with that? Yes, good. Cool beans. All right. Are we ready to go on to the next question? Okay, I think so. All right. So let's have a look. Cool. Ready. All right. So let's look at this one. Here, my mouse does this from time to time where it just, hang on a second, guys. Plug it back in. I'll just see if I can make this question. No, it's still not cooperating. Okay, it'll hopefully cooperate now. All right, so I hope you can see this okay. It tells us that the height of 160 learners in a school are measured. The height of the shortest learner is 1,39, and the height of the tallest learner is 2,21. Wow, that's really tall. The heights are represented in the histogram below. Okay, describe the skewness of the data. Is this bringing back grade 11? Okay, so can you see less is positively skewed? So when we're talking about a skewness in the data, what are we looking at? I mean, if I was to draw a box and whisker plot, right? And our box and whisker plot looked like this. What would we say? Yes, this would be skewed to the right, quite right. So this would be skewed to the right. So we would also refer to that as positively skewed. Okay, absolutely. So there are more values, Tisha, that's quite right. So in other words, because our median is our point in the middle, right? So there's going to be a bigger range from our median to our maximum than there is from our minimum to our median. Okay, so quite right, this is going to be positively skewed or skewed to the right. Okay, so positively skewed. And then if you also said or skewed to the right. they would also give you 1 mark. Okay, so either one of those 2 answers. Now they want us to calculate the range in height. There we go. Now I can finally make this a little bit bigger. So, how are we going to calculate the range in people's heights? I'll go back up to the information that was given to us. Can anybody tell me how we would calculate the range? There we go. Exactly. So the maximum minus the minimum. All right. So we agreed that this data was positively skewed or skewed to the right. Let's just put that in again. And here our range is going to be, as you said, Kaiser, our maximum. So what's the tallest person? How tall is the tallest person? The tallest person is? It's given to us, 2,21. That's it. Okay, 2,21. And the shortest person is also given to us. And they are what? 1,39. That's it. What did you say, Kanisile? 0,82, that's it. Okay, so that's the range in height. Now they want us to complete the cumulative frequency column. Oh, rats, did I not? No, got that. Oh, bugger. Now we want to draw the ogive. Hang on a second, let's just have a look here. I'm so stupid. I didn't pull the cumulative frequency column out. So we're going to need that to be able to draw the ogive. That was stupid of me, wasn't it? Nelisa, should I just go and quickly have a look where I got this question from?
Yeah. Okay, I can do that for you in the meantime.
It was, you want to look for this question?
Yeah, but then would we have to share it though?
Because yeah, because the thing is that they would have then decided, they would have given us in the table, they would have given us, okay, I mean, we can see obviously what the intervals are. Then again, no, hang on a second. We can actually do this from the ogive, can't we? Because the thing is, okay, let's just make our own one up here. So we've got 1,3. So let's just say that x is great. We don't know this is true, but we just have to include one and not include the other. So 1,5, and then we would have 1,5, which is smaller than or equal to 1,7, and then 1,7 is smaller than or equal to, it would be 1,9, and then 1,9, and then here it would be 2,1, and then it would be 2,1, and then here it would be 2,3. Okay, so we know that there are 24 people that are between 1.3 and 1.5. So now in order to work out our cumulative frequency, what does cumulative mean? Cumulative frequency. When we say cumulative, what are we doing? Where does the word cumulative come from? Matrix, do you really not know what the word cumulative means? Okay, it doesn't. I can see why you're saying that, Pumezo, but that's not 100% correct. It's a good answer, but it's not 100% correct. Okay, so if I use the word accumulate, what am I saying? What does the word accumulate mean in English? Can anybody give me a simpler word for the word accumulate? Yeah. So if, okay, you guys know who like Elon Musk is, right? There we go. That's it. That's it. Okay, so it's added up to, it's been collected, it's been added to. Okay, so accumulate means to collect or to add up over a period of time. So cumulative frequency means the frequency that has been added up over time. So what it tells us at any particular interval, how many people or things fit into that group or less. So what I'm going to do in order to do, so hang on a second, what I'm going to do now, sorry, it's just, okay, gosh. So my frequency column, if I have a frequency column here, and then over, whoa, hold on, sorry. And then over here, if I have a cumulative frequency column, let's just have a look at the difference between the two. Okay, so how many people are between 1.3 and 1.5? There are 24, right? How many people between 1.5 and 1.7? 71. And then there are 38 people that are between 1.7 and 1.9. There are 23 people that are between 1.9 and 2.1. And then there are only 4 people, right? So how many people in total took part in this survey? What do all these numbers add up to? How many people took part in the survey? Are you getting 160? Yes, there we go. Okay, and that makes sense just because look at the beginning of the question. It says the heights of 160 learners in a school are measured. So we know that this has to add up to 160. Okay, so N is 160. So cumulative frequency does this, right? Is that it considers the people that are between 1.3 and 1.5. And then in this second row over here, we're going to add 71 to 24. So we know that there are 95 people that are 1.7 meters or less. Okay, same thing with the next one. We're going to add the 38 to the 95. So now we know that there are 133 people in this survey who are 1.9 meters or less. Okay, now add 23. What do you get? That's it. And now what happens when you add the 4? Okay, exactly. All right, we get back to 160. So we have to get back to our total. There we go. Right, so they would have given you a table that was typed, not like the one that I've just drawn here, and you would have had to fill in that cumulative frequency column. Is everybody happy with that? So that's how we would have done 2.2. So the answers that they would have been looking at would have been, you know, the 24, the 95, the 133, the 156, and the 160. Okay. Now we have to draw an ogive. Do you know? Yeah. I'm sure. Everybody else? Okay. All right, cool. Okie dokes. So now in the next question, they want us to draw the ogive or the cumulative frequency curve. So when we draw an ogive, so this is what we're going to draw it on. We've got the heights of the learners on the x-axis, and we've got the number of learners on the y-axis. Our ogive has to be anchored on the x-axis. It has to have an x-intercept. How do we know what our x-intercept is? Because you're going to get a mark for this, right? So you have to know what your x-intercept is. It's a good thing we spoke about this evening then, isn't it? Okay, so your x-intercept is always going to be this value over here. So whatever is your minimum value in your smallest interval on the left-hand side, that is going to be your x-intercept. So for any x-intercept, x will be equal to whatever, and y will be equal to 0. So in this case, our x-intercept is going to be the point 1, 3 plotted against 0. Now, there are certain situations where it would make sense for our x-intercept to be at the origin. So in other words, x is equal to 0 and y is equal to 0. But in the context of this particular question, when we're talking about height, it doesn't make sense for our x-intercept to be at the origin, because no student at school is going to be 0 centimeters tall or 0 meters tall, right? Does that make sense to everybody? Good. Okay, so whatever this number is over here, plotted against y is going to be your x-intercept. So in this case, it happens to be 1.3 and 0. So that's going to be our x-intercept over there. Then what we're going to do is we're going to plot our upper extremity over here against our cumulative frequency. So we're going to plot 1.5 against 24, and 1.7 against 95, and 1.9 against 133. Okay, and then what this is going to do, and then 2.1 against 156, and 2.3 against 160. And what this is going to do is it's going to create a curve that is S-shaped. Okay, so it's going to increase quite quickly, and then it's going to and then it's going to level off. Okay, all right, so 1.5 and 24. So 1.5 Hang on, let's get my pen. 1.5 and 24 is like right over there, isn't it? And then we've got 1.7 and 95. So now can you see here, it's got a really steep gradient because it's gone shot up all the way to 7 and 95. So that's that over there. I'm so glad to hear that, Mr. Bavuma. That makes me very happy. I could do this all day too. All right, next one is at 1,9. I can hardly read what I've written, guys. Yeah, 1,9 and 133, 1,9. Okay, so that's this line over here, 133. Okay, so there's 130, right? So 133 is kind of in the middle. And then 2.1 and 156. So 2.1 is the next line over. What? And 156. Yeah, I thought I said 256, but I didn't. Okay. And then 156, where is it? Where is it? It's 155. So 156 would be about there, right? And the last one, 2.3 and 160. 2.3, so that's this line over here, and then 160. Okay, so look at the red dots. Okay, can you see that it makes a curve, a sort of S-shaped curve? And the correct way to draw this is to make sure that when you draw the curve that you go through every single one of these points really carefully. But it's kind of like when you're drawing a parabola or a hyperbola. It's a curved function. So it needs to be, whoopsie daisy, it needs to be a smooth curve, which I'm going to attempt to draw as best as I can, but forgive me if I don't get it 100% correct. That is horrible. Sorry, guys. Hang on a second. Let me just delete that. Try and get this right. Don't judge me, okay? You do as I say, not as I do, all right? I'm trying. There we go. Okay, we got it grounded. Okay, so it's supposed to look something like that, a little smoother than what I've done, but that's the general idea. Okay, our cumulative frequency curve. All right, and then we can see here that they've given us 4 marks to be able to draw that. So it's quite easy. What do you think those 4 marks are for? How do you think the 4 marks are allocated to us? %. Okay, so x-intercept, definitely. Shape, all points correct. Yeah, I must be honest, I'm not 100% sure what that 4th mark would be, but shape, x-intercept, all points correct. All right, I don't know what they gave an extra mark for, but all right, nice for us that we got an extra mark for, I don't know what. And that's what it should look like. So the last question here, now they want us to use our cumulative frequency curve to estimate. So 80 learners are less than X meters in height. Estimate X. So what do they want us to do? 80 learners are less than X meters in height. Estimate what X is. So what am I looking at? $80 learners are less than X. So where do they want us to go? Which axis do they want us to look at, Matrix? If they're talking about 80 learners, are we on the x-axis or are we on the y-axis? Precisely. Okay, so we're going to find 80. And now you would do this with a ruler, right? So we're going to find 80. So I'm going to find 80 as well. And I'm going to go. Oh, it's not very good, is it? That's not too bad. I'm going to go across. And then I'm going to go down. Okay, so that I can estimate what x is. So I'm going to read off the curve what the value of x is going to be when y. I do not like what I've done here. Okay, so that should be slightly over. No, okay. Slightly over to the right-hand side. Let's have a look. There we go. That's better. Does that make sense to everybody? 1.6 like. So here they would have to be, so they're asking you to do an estimation. They would normally give you a little bit of leeway on either side. So it would have to be more than 1.6, but less than 1.7. So if 1.6 is directly in the middle, right? Let's just do that in a different color. Red. So if 1.6 is over here, I'd say it's sort of halfway in between 1.6 and 1.7. So 1.63, 1.64, do you agree? Yeah? There we go. They would give us a little bit of leeway either side. Okay. Are we all good?
Okay. I'm gonna post the link to the quiz on the
Do
chat.
I think we've had a all right. Okay,
Yeah.
so for those of you that are writing physics tomorrow, all the very best. Hope it goes well. You're nearly there. Just hang in there, okay? You guys are nearly done.
Yeah.
Are there any questions you guys want to ask before we say goodbye? It's a pleasure, Kaiser. Always a pleasure. Pleasure, Tisha. Thank you for the rose. Thank you.
Rose. Beauty and the Beast. It's all started rose.
Sure, Kulani. Just give me 1 second. Is that down far enough, Kulani?